For power levels up to 150 watts, conventional quasi-resonant flyback controllers can be used. There are some excellent guides on how to design flyback converters provided by power supply controller manufacturers, and this guide is not intended to replace these. This guide is primarily to provide clarity on specifying the primary side inductance needed for discontinuous conduction mode, after which the design of the flyback can be completed using the documentation from the manufacturer. It's important to design the flyback so that the maximum output power can be provided over the full voltage swing on the HVDC. In order to do this, the flyback should operate at a minimum voltage, for example 65 volts, at the controller's maximum duty cycle. The peak current is then calculated using the formula shown, where eta is the efficiency of the flyback converter. In most designs, eta is typically 0.9. The minimum voltage across the primary side inductance of the flyback is linked to the inductance, switching frequency, and maximum duty cycle by using these equations. The maximum on time of the primary side switch is identified by Ton max. This nomogram shows the relationship between these parameters. As an example, if the controller duty cycle has a maximum value of 45% at a switching frequency of 52 kHz, this determines an on time of approximately 8.6 microseconds. If the peak current is 4.6 amps, then a minimum voltage of 65 volts requires a primary side inductance of 122 microhenries. With this primary side inductance at the maximum voltage of 350 volts, and for the same peak current, the on time is 1.6 microseconds, which at 52 kHz results in a duty cycle of 8.5%. It is essential to check that the flyback controller supports these duty cycles and switching frequencies. For flyback controllers that offer variable switching frequencies, this nomogram can still be used to ensure the voltage swing parameters map to suitable duty cycle and frequency values.